Hi, welcome to video number 6. In the previous video, we got started with static analysis by building a set of classes which we're going to use to build a representation of the program, or so-called intermediate representation. For example, programs are made up of a sequence of statements. A print statement has an argument, assignment statement has a target, a source, a variable declaration has a variable and an initializer, and the variable has a name and a type, and so on. We're able right now in our analyzer to build up a program representation, but it doesn't have any type checking. It doesn't respect any scoping rules or anything like that. But we got a pretty good start on it. And if we were to run the tests on it, as we saw in the last video, we have all of our tests passing, but we have a lot of uncovered code. We don't have any real tests to speak of. Our analyzer test does one thing and one thing only, which is to take the program print 0 and just show that we get a program representation out of it, which really just has a program and a single print statement inside of it. Okay, we're going to do the actual analysis in two parts. In this video right now, we're going to be working on type checking. And in the following video, we're going to be working on issues of scope. So let's get into type checking right now. Oh, where do we start? Okay, well, the idea is basically certain things have to, certain entities that are expressions have to have types. For example, in a while statement, yes, we have a test and we have a body, and we would like to say right here that the, let's just say must be a Boolean test. We want to know after, analyzing this test expression right here, it had better be a Boolean. If it's not a Boolean, we would like it to fail. We would like to throw an error. If we, for example, see, well, I think down here we have some expressions. Here we have relational operators comparing conditions. We would like to say over here something like must be a number left and must be a number right. I think we should put that right under here. It might make more sense. And if this was the case, okay, we want the left to be a number, we want the right to be a number. And when we're comparing two things, we want the result to be a Boolean. So we like to be able to say over here that the resulting type over here was type Boolean, which, have we defined Boolean yet? Let's see. Do we have any types? What should we do over here with types? Types. Okay, let's take a look in core. And no, the only type we've defined so far was void. Let's put in Boolean, number, and string. Okay, that should be helpful. Let's put in a Boolean type, and then we'll put in a number type and a string type. All right, well, that's good. Now that we have these in our analyzer, we can go ahead and say that when we build a binary expression, we'll be able to assign to it a particular type. And this idea of type checking simple expressions can carry over into our additive. Okay, so terms plus factor, no, sorry, expressions plus terms, the multiplicatives, the terms times the factors, and the exponentiation operators, primary to the power of a factor, and negation, where we would just negate in integers. So we'll put in the type checking and type generation for those four right now. Okay, so for conditions, we must have two numbers being relationally compared to produce a Boolean, two numbers being added to produce a number, two operands being multiplied or divided or remaindered, number, two, number. And for binaries, we have must be a number left, must be a number right, and we want to produce a number from that. And from the negation, we must have a number before we negate it. So let's say over here, must be a number, which is our operand. Yeah, I'm just noticing something right here. this operator right here, looks like I forgot to actually say const. I'm kind of surprised that VS Code was not complaining, probably because I'm using JavaScript instead of TypeScript. So before we have any trouble, let's mark those things as being constant. Okay. Oh, and for the unary, we need to produce a number over here, core type number. Does unary expression expect a type? Yeah, it does. That's good. Okay, so now we have to put in these checks over here. Must be a number and must be a Boolean. Let's get these checks here in the top. So we'll write a function must be a number given some entity. We want the type of this entity to be a number or else. So something like, right, if e type is not equal to core.type.number, that's going to be a problem. We want to throw an error, throw a new error. Now, this is fine for right now, but something must be a number. So maybe number expected. It's actually better practice when doing validations and checks to have a generic test method. So function must, and it'll take in a condition and an error message to use of it if we don't have it right. And we'll just say here, if a condition does not hold, then we want to throw a new error with our error message. And then must be a number. It's just, it's going to change to this. We'll give this the condition and number expected like so. And we should do one for Boolean as well. So let's handle must be a Boolean or type Boolean with Boolean expected. And let's give ourselves some space. Let's make sure you didn't break anything. Always a good idea when we start adding stuff. I want to make sure you don't add in something that wasn't there. Okay, good. 46 tests passed. Let's get some tests in here before we get too far ahead of ourselves. I mean, we already are too far ahead of ourselves, but what are you going to do? Let's get some tests in. All right. Right now, all we're testing is that a given source code program gives us what we expect. We'd like to expand our tests a little more to deal with cases in which we have things that we know want to fail and things that we know that want to succeed. And we're going to take the same approach we did with the parser test, and we're going to build up a collection of cases that we want to fail with expected error messages, as well as cases that we would like to succeed. All right, let me drop let's get started with a few right now. So here we go. I have just to start, I just primed our tests with two programs that I think should work: print 3 less than 5 and print 7 minus 2 plus 5. And then here are some things that should not work. Printing false plus 1 should be illegal because we shouldn't be adding Boolean, and we should not be multiplying with strings, and we should not have non-Boolean test cases here. And here in the test case, similar pattern, you've probably seen this before. Iterate through all the good programs with the name scenario and some source code. It should recognize it okay. We should be able to parse and analyze it without any errors. For bad programs, we have a scenario, we have the program itself, the source code, and we have a fragment of an error message or pattern or regex piece of the error that we would like to see thrown. We want to assert that it throws on that particular case. Let's run this, hope for the best. I actually think it is going to fail because we haven't actually, we haven't really typed everything yet, Like for the while test, it did not throw an exception over here. We actually have some other problems here. Look at this, missing semantic action for primary parens. What is the meaning of primary parens? Well, here, primary parens looks like we have a semantic rule, or sorry, we have a syntax rule that doesn't have any semantics for it. Let's make sure to get that in. That was a bit of an omission. So let's go to, oh, actually, we don't have anything for primary. Oh my gosh. So primary parens, it's a good review. It's a good review of of how to do this stuff in Ohm, we had an expression in between an open parenthesis and a closed parenthesis. To get the representation for that, it's just going to be the EXP rep. That's probably all we need over here. And don't forget your commas because these are just methods. Let's try that again. What do we see? Some other things failing. Okay, missing expected exception, missing expected exception. Oh, looks like we have a problem over here. Let's find out what's wrong over here. Oh, number expected for additions. It was supposed to recognize additions, and oh, it could not find a number. So right here, must be a number, was called from this binary condition here. And I think what we're trying to do is we're trying to do what, 3 less than 5, was it? Something like that. Yeah, 3 less than 5. And when we analyzed the left-hand side, it was not a number. Now, why is 3 not actually a number? Well, we never assigned a type to that. How are we going to assign types, right? How are we going to give a type property to numbers, right? Well, perhaps you may have heard of something called monkey patching. It's very controversial. Some people would like never do it. But you know how we could have a string like dog, and then we could say, hey, what's your type? Well, of course, there's no type property on dog, but if we wanted to say that string dot prototype type was, for example, something like, I don't know, str, just to make something up. Now, if I ask for dog.type, I can get str. I mean, I can actually attach properties to existing strings and booleans and numbers and things like that through this technique of monkey patching. It's kind of, like I say, it's pretty controversial. But if we wanted to, we could do it. And I'm just going to do it right here because I can. I'm actually going to attach the type number to all of our numbers. For Booleans, I'm going to attach the Boolean, and strings are going to get the string type. So with this little round of monkey patching here, let's see if anything that works. We're expecting something. Well, not everything works. How many tests fail? Well, we still, similar test failed here. We cannot recognize comparisons or additions. We didn't have a while test pass. Okay. Oh, we still have number expected. Why do we have number expected? Let's see. Where was the number expected thing happen? We're trying to do recognize comparisons. Oh, we still don't have this thing being a number yet. Basically, I got the conditions all wrong. This is what you get for copy pasting. When you're trying to do validation, you want to put in this is the condition that you want to hold. You want to say that this must be a number and this must be a Boolean. So I had it backwards. Apologies, you probably saw that. And now all of our tests pass. Yay. Okay, so what just passed? What have we actually done here? We've put our tests on our while statement. We've got tests on our conditions and expressions and terms and factors and all that good stuff. Okay, but there's a lot that we haven't yet done. We should probably get a test in here for negation and exponentiation as well. Again, let's not get too far behind with our test. Okay, tests are added for exponentiations and negations. We have a failure. It's kind of good to have test failures. Operator is not defined. Operator is not defined here. Oh my gosh, need a const. Yep, that's good. JavaScript checking us, or VS Code checking us. Okay, good. 53 tests pass. That is helpful. All right, let's try to get some more types checked here. Maybe, well, we did strings, Booleans. We're not really using strings for anything. Oh, how about for assignments? Okay. When doing an assignment, we want to make sure that, got to make sure a couple of things. we want to make sure that the variable has already been declared and that the expression that we're assigning to the variable has the type that the variable is constrained to have. That's going to be interesting because this is something that we haven't really even thought of. Let's for example, go into, let's make an examples folder. So I just made an examples folder between the last two videos and create a little file here, which we're calling small.pitch, a little small program right here. And I started thinking about, okay, if we declare a variable, let's call it X, we should be able to print it. And this should be totally fine. We should not be able to say print Y if Y is not declared. So something like this should be an error. And however, print X, this should actually be okay because X was already defined. I was also thinking about type checking arrays and dealing with things like this. I kind of want this to be an error because we're starting to mix things up like so, right? And we'll worry about these things later. So to type check assignments, what if we were to assign, say, X now to 100? Well, this should be okay because we know when X was declared, it should be constrained to being a number. But if trying to assign false, we should make this be not okay. In other words, we need to attach type constraints to variables, and variables should get their type constraints when we get the type of an expression. That's going to be the type we want to associate with a variable. Now, in the core, we've already talked in the last video about how variables are going to have a kind of, they're going to have a type, and we need to associate the type with the variable. How do we do that? Well, it's going to be done during the variable declaration. This one's actually not too hard right now because what we can do when we have our variable declaration, we're making this variable, the variable right here should have a type that is the actual type of the initializer. I mean, it's that straightforward. So this part actually is okay. We analyze the initializer, and then the variable is going to come back and have the expected type. That's okay. But the difficulty is going to be if we want to do something like assign to that variable or use that variable or print that variable in any way, we have to look it up. So let's look at our sample code here. Yeah, I can do let X be 3. That's fine too. But if I want to print X, or if I want to do something like print X times 5, how do I know that this X right here has type number? I created a variable of type number right here, but when I come back around to multiply it, I need to know that it has that type. So again, I created the variable here, but what did I do with that variable? I have to put it somewhere. I have to save it somewhere so that later, when I come all the way around, and say, hey, let's look up the variable over here, it has to go somewhere. And the answer to where this thing goes is that we create something called a context. The context is where we're going to put variables that have been previously declared. So we declare them, we put them in the context, and later we want to look them up. So what does a context look like? Well, basically right now, a context is just going to be a wrapper around a JavaScript map, a map holding local variables. When we declare, we're going to want to add a variable entity to the context with a given name. And if we ever need to look it up, we'll call lookup on the current context, and we'll grab the entity associated with that name. Now, the entity right here, I've used the term entity and not variable because we're going to store in the context not just variables, but also functions. So the idea of an entity in programming is that entities can be variables or constants or functions or tasks or you name it. They can be many, many different things. So we're just going to call them an entity for right now. When we analyze our program, we're going to do it with a context, right? We'll talk about what gets loaded in the context first, but for right now, we'll have a context object. When we declare variables, we're going to not only after creating this variable, what we want to do here is add it to the context. So context.add, now the name of the variable is whatever the variable's name was, right? The ID source string, and we'll add the variable. So the variable is now added to the context. When we look the variable up, or when we have an identifier appearing in an expression, say, I want to do our lookup here. We want to be able to say, hey, let's go into the context, look up the name, which is the ID's source string. That's going to be our entity. And we want to make sure that it's there, for example. Let's do look up. So let's make sure the variable is actually there. So we want to say must be, let's say must be declared, whatever that entity is. And then if it is declared, we can return it. And there we go. Okay, so let's implement must be declared. And all we need for must be declared we just want to make sure that it's not undefined or null or something ridiculous like that. So how about we just say must e, and we can force it to be a Boolean with that old thing. And then we can just say something like e is not declared or something, or identifier not found. That's actually if you think about it, that's not a very good error message, because like, all right, like what's not found? So this is probably not a very good, not a very good way to do it. Let's see if we can do this a little better. Let's see if we can actually get the name in here. So maybe it must be declared. Why don't we just pass the ID around? We'll pass the ID as a second thing. And then we can just say, all right, must be declared E, and then we'll say ID. And then right in here, we can just say, rather than just saying identifier, we'll say ID dot source string, not found, or no, we'll just say not declared. Okay, and then we're using the wrong one of these things. Okay, there we go. So now I can do must be declared. So we're getting a little bit ahead of ourselves. Let's make sure to get some tests in place. All right, so here's a few tests. Here's a test that's good. We're saying that if we declare it, we should be able to see it in the print. And here are 3 cases in a print, in an addition, and in a negation, where we're using variables that have not been declared. And let's see what breaks. Oh, good, it definitely breaks. The error message argument is ambiguous. What did we do here? Okay, this is actually pretty strange. The error message argument is ambiguous. X not declared is identical to the message. Strange error. And not strange at all. I mean, it's kind of expecting that we're using patterns and we're not actually using strings. This is not, I should have known. Look at that. It just didn't look anything like the lines above it. Typical. Okay, there we go. It's all passing, 57 test passing. Okay, making progress on our type checking, but there are other things that have to be checked. For example, hey, look at that. We're gonna do calls in the next video, so hang on. What else? Oh, how about assignments? Okay. I think I said earlier that once we declare a variable, that variable has a type constraint. And if we try to assign an expression to it, the types have to match. We're gonna have to do some type checking matching. Okay, so I'm gonna say, first of all, to simplify things a little bit, I'm going to actually, instead of doing the reps in line, we're going to compute the representation of the target and the variable first. Okay, that way we can start doing, that way we can do a check to see the source, the thing we're assigning from, like if I said, you know, I don't know, X is 5 or something, 5 would be the source and X would be the target. The type of this has to be compatible with, has to be assignable to the target. So I want to do a check something like must be assignable. And we want to be able to assign the source to the target type, something like that. So if I said X is assigned 5, you want to make sure that 5 can be assigned to whatever the type constraint on X is. So let's do must be assignable with our source and our type. Putting in a lot of checks over here. This is normal. Must be assignable. And we have a source and we have a target type. And how do you want that to look? Well, it's certainly going to be the case that I want it to be the case that either the source, the type of the source is exactly the target type. I mean, that's one way that it could work. But another case is what happens when both of these two types are array types, because the Pidgin language has array types. And every time we count array type, we're like making a new array type. And so if that were to be the case, for example, if the source type was an instance of the array type and the target type was an instance of, oh, I have to say core.array type, don't I? Then, okay, and that has to be the case if those two are both array types, then the source type, base type must be the same as the target type, base type. There might be better ways to do it. Anyway, with that prettier format and everything, which is kind of nice. All right, so probably should do some tests for this. Always a good idea to put in tests. So let's put in some okay, let's signs. Okay, so let X be 3, and then okay, X can be, I don't know, 10 to the power -2 or something like that, or 10 to the power 7 minus 2. Woohoo. And then let's do an assignment of, let's try and assign nums. We'll try and assign some bools, and we'll assign arrays. Okay, I'm just copy pasting over here. Actually, assignment of arrays doesn't work because we haven't actually typed the arrays yet. But let's get a type mismatch over here. Actually, what did we do for type mismatch? We said must be assignable. What if this is not the case? I forgot the error message over here. We can say over here something like, for right now, we'll just say type mismatch. Okay, forgot the error message there. So that's why I write tests, so we know. So we'll try to say, I don't know, let's let X be 1, and then we'll try to assign false to it. And this will be a case of, what should it reject? It should reject the assignment of assigning a bool to a number. That should be rejected. And then over here, we'll just say type mismatch. Run the tests. Yeah, it actually worked. What do you know? Speaking of arrays, though, we have not actually given any types to arrays, and that's something that we should probably handle right now, because arrays are actually some perfectly good types here. So where do we actually deal with arrays? What kind of it? Let's write the test first. Okay, so it should be okay to assign arrays. Now we haven't done anything for the arrays yet, so let's like write this thing and then watch it fail. So we should be able to say, all right, let X equals this, and then we should assign to it another array. Maybe we'll just do one with a 10 over here. And this is an array of events being assigned to an array of events, or numbers actually in this case. Maybe we should add numbers in the future video. Okay, we do have a test failing as expected. Oh, well, the test failed like expected, but not for the same reason. We had just forgotten semicolon. Running it again, we find a failing test because, ooh, look at that, no primary array. Missing semantic action for primary array. Primaries have arrays, which are lists of expressions, which we did not take care of. Okay, just like we didn't do primary. Boy, let's get this in here. Primary array. And this had an open bracket. It had elements inside of it, and it had a closed bracket. And what do we need to do in here? Okay, let's talk about what we need to do in here. All right. Well, elements is going to be one of those list of nodes. So we need an as iteration. And then there's the children of that node, because once we do add it or as iteration first to get our sequence, then we run children on that, and that will give us all of the children nodes. And then we can map each element to its program representation. And what can we do with this? What do we do with these things? Oh, it's crazy how it's split up like that. These are going to be all of the elements that are going to go into the actual array expression. So we would say return new core dot array expression, and the array expressions require elements. Now, if I look at the core for the array expression, do they need a type? Well, every expression needs to have a type. Every expression needs to have a type. What type would this be? Should we pass in the type? I mean, we could pass in the type. I mean, we could also, oh my gosh, what happened over here? I forgot braces. That's not good. All right. We should put in here array expressions can actually have, we can assign a type of, no, you know, let's just pass it. That's fine. Let's pass in the type. And how do we pass in the type? So what is the type going to be? It's probably going to be the type of the first array element. Interesting though, right? Oh, wait a second. Look at this, is not good. The primary array gets a bunch of expressions. The elements is going to be the expressions dot as iteration dot children. No, not like that. Children. There we go. Okay, so we take the expressions that are separated by commas. We put them into a sequence node for ohm. Then we iterate through its children by computing the representation for each one of them. As iteration gets parens, children does not. Then we can return an array expression that has the type of the first element. Only, what if the array is empty? Okay. If the array is empty, this is a bit of an issue anyway, because if I had an empty array, I would not know what its type is. Type of what? How would I give a type constraint on P? Because Pidgin does not allow us to put in a type constraint right here. I mean, maybe it should, but for right now, it actually doesn't. So I think just for now, we're gonna right now, until we get our test and pass, we're going to disallow empty arrays. And how do we disallow empty arrays? Well, we go into our grammar and we say that it's a non-empty list. Ohm lets us do this. If I say it's a non-empty array, then I can certainly work with this here. Let's see if the test pass. That might have broke something because maybe I had a test with an empty array. Problem, love to find problems. Elements is not defined here. No, wish I would have tipped me off for that in the editor. How to use TypeScript, people. Okay, all the tests pass. That's okay, but I can see that we need another test here, which is to say that we don't want arrays of mixed types. So I want to reject arrays of mixed types. In fact, I do not want an array that looks like this. That I do not want. If I'm going to use quotes in there, I better use something else. Mixed types in array. How about we reject that? Right now, we're not actually checking those types. So I expect that test to fail. It fails because there's no semicolon. It's what you get for design languages with semicolons. All right. Test failed as expected because no exception was thrown. No exception was thrown because we did not check that must all be same type of the array elements. That's what we need to check. All right. Let's do this check first. Must all be same type. Function must all be same type. Elements, and we'll get the type of the first element, first type, and then we'll check all the other elements starting from the first element, slice one, make sure that all those types are the same as the first type, the type of the first element of the array. Run those tests. Still a problem, all same, not defined. Because why? Oh, geez. I don't know, I'm always missing const there. That's ridiculous. Okay, show me the test pass. Oh, still don't pass. This is okay. All same type, not defined. Oh, all same type. That was a rookie mistake. Twice got it wrong there. Boom, missing expected except, oh, no exception was thrown. Must all be same type. So I got the first type here and I made sure that everything else was the such that it had, and it must all be the same type. Missing expected, so an exception was not thrown there. That's pretty interesting. I have my elements. It must all be the same type. Definitely passing in an array of things that should have a type. Getting the first type, and I'm taking everything else and checking. Oh, not map. Every, oh my gosh. Four little mistakes in that one simple function. Ta-da, all tests are passing right there. Okay, know your JavaScript, people. That's all I can say. What's next? What other things do we have to check? I can think of one more thing that I want to check now in this video before moving on. And that is when you have a subscripted value, something like this, assuming that I did have an array of strings, for example, I would like to know that something like this subscripted expression should check out. In this case, the variable here should be of an array type, and the subscript should be of a number type. And the whole expression, the entire expression right here, needs to have the type, which is the base type of the array. And we can work on that. The first step would be to get to the variable in the EXP representation computation out of the call and into separate variables to make them easier to check. And once that's done, we can put in little checks. Must be an array, and something like must be a number. We already have must be a number. Woohoo, subscript. And then our subscript expression, we can give it a type, and the type is going to be the array's type, base type. And do we actually have subscript expression? Does this take in a type yet? It does not, but we can give it a type. You can pass in a type here. You can probably argue that the type assignment could be done inside of the subscript expression itself. We can consider that for refactoring. What we do need to do is we have to handle must be an array. So I already have must be a number and must be a Boolean. Let's add must be an array. Okay, that's added here. That's not too bad of a deal. It's a little different though. We're not actually doing an equality check. We're doing an instance of because there are multiple array types, not just one. Definitely requires some subscript tests over here. So it must handle subscripts properly. Subscripts, and maybe let A be true and false. And maybe we could print A of 0. If we actually had, oh, careful there, always putting your commas here. Let's just see subscript, what I want to do over here is let's let A be 1, 2, 3, and I want to make sure that A sub 0 minus 5 works. So we want to check that A sub 0 is actually a number. And we can just do a subscript as a number. And let's do subscripted. Subscripted is a number. And we can allow, so that's allowed, and subscripted is a Boolean. So if A were to be something like false, then we can say, just doing a check over here, while A sub 0 do nothing. These two things need to pass. What we're testing is to make sure we have the correct typing output. And of course they don't. So I think this is semicolon again. Array type is not defined. Okay, that's because of core. I imported everything in there without, sorry, I imported star as core. Okay, that's just, oh, more failing tests. What's failing now? Array is expected, recognizes subscript. So a failing test, it said an array was expected, that A is false. Oh, you know what? I think we're getting the same error for all of these as well. It's not even liking the first part of the subscript. Array expected also. So somehow or other when I'm doing A, this is actually not coming out as an array. And so for that to happen, then A is probably does not have the right type. Okay, so A is actually not an array. So let's see how we actually generated the type for those arrays. See right here, we're checking, this thing must be an array. And we're checking these prime, oh, here it is right here. The type of an array, yes, we can go through all the elements and find out what their type is, but the actual type, the type of this whole array at the end is going to be a new array type whose base type is elements 0.type. That's what it is. So I think that's what it is anyway. Let's see if that gets some test passing. When it does, okay, and then to make sure we're really writing out the right type, it's probably a good idea to just put in some checks to make sure that we're in a bad way. Let's see if we have, we want to reject subscripting a number. So we definitely do not want something like let A be 2 and print A of 1. This should be something that is wholly rejected, don't you think? We should totally reject this. And this would be something where we're looking for array expected. Let's see if we get this one done. And then that should be rejected. And then we should also reject, yeah, it does. Okay, we should also reject non-numeric subscript. Let's reject this one and say something like let A equal 1, 2, 3. And we do not want to be able to print a false. That should be rejected with the message number expected, I believe. Okay, that got pretty long. Let's keep our code a little more of a one-liner there. All righty. And with this one, yeah, okay, cool. Thanks, Passing. Okay, so this is the basics of type checking. Now, we haven't type checked everything yet because we have not yet dealt with function declarations, and function calls, and how parameters have types. Now we have to check the type of the return statement to make sure that it's compatible with the declared type of the function and all that good stuff. But dealing with functions is a more complicated thing anyway, because it requires that we deal with things like scope. And we're going to be building a new context and everything like that. So we're going to handle the type checking of functions while we talk about scope. But this was the introduction to type checking. This is kind of how you do it if you don't have much, if you really don't have functions or nested scopes. This is good enough for simple scripting languages. Thanks for watching. See you in the next one.